Hi students, a very pleasant and warm greetings to you all. Hope you all are doing good. You would have completed the first chapter, right? You would have attended the first chapter classes and you would have read the book and you have taken notes and you have learned, and I hope that you are clear with the first chapter, right? Introduction of computers lesson, you are clear with it, right? If you are not clear, as soon as attending this class, just take your book, read the whole chapter and take notes in your note and learn the questions, book back questions also, okay? And now we are moving to third chapter, okay? Second chapter is number system. It will be difficult in teaching through online. If possible, I'll make a separate video and I'll upload it soon, or else we'll see it at last, okay? So I'm moving to chapter 3. Third chapter is computer organization. This is common for both computer science and computer application students, okay? Today we are going to learn about computer organization. Computer organization means it deals with both the hardware and the internal things, okay? What are the interconnections done there? In this chapter we are going to learn what all are the components inside the CPU, what are the process going on inside the CPU, what are the interconnections done there. These are all the things we are going to see in this computer organization chapter, okay? It includes the input and output devices, the processing unit, the memory, the primary memory. These everything will be included in this computer organization chapter, okay? Now let's see, computer organization deals with the hardware components of the computer system, okay? It includes the input and output devices, central processing unit, storage device and the primary memory, okay? We have input device, output device and central processing unit, right? Inside this processing unit, what are the things you have? You know that it has arithmetic and logic unit and register and a control unit, right? Now first we are going to see the basics of microprocessor, okay? In this basics of microprocessor, CPU is the major component of the computer, right? You can when you are using a computer, you can just change the monitor, you can just change the keyboard, you can just change the mouse, but nothing will be changed what is saved inside, right? Because everything is saved in the CPU. Once you change the CPU, the whole content will be changed, okay? Even if you change the monitor or the desktop, the screen is there, right? That desktop, if you change also, if you have the same CPU, if you keep another monitor, you will get the same icons there and the same things which you saved in the previous desktop, because the things which you save are saved inside the processing unit, the CPU, right? So the CPU is the major component of a computer, okay? This CPU only will perform all the tasks, okay? This is realized by the microprocessor, okay? Now we are going to see the basics of microprocessor, okay? This microprocessor is an integrated circuit, and this is introduced in early 1970s. That means in 1970s itself this microprocessor was introduced, okay? This first general purpose microprocessor 4004 was developed by Intel Inc. Okay, this microprocessor 4004 was developed by Intel Inc. What is that Inc? Intel Inc, right? Inc means it is incorporated, okay? There is a corporate company which is Intel, and this Intel only developed this microprocessor, okay? And this microprocessor means it is a programmable multi-purpose silicon chip, okay? You have to remember this line, programmable multi-purpose silicon chip, okay? This is a chip which is made of silicon. This is used for many purpose. That's what they are giving us, multi-purpose, okay? And this is programmable. We can give some instruction inside that and we can design it. So this is a programmable multi-purpose silicon chip, okay? This is driven by clock pulses, and when you give a input, it will be taking that input as a binary data and then it will process. As per the instructions, it will process the data and it will give you the output, okay? When you see this block diagram, you can understand it. See, input is given into the microprocessor and it the data will be stored in the memory and the processing also will be done, and then the output will be given out. Okay, this microprocessor has three units. Okay, first one is arithmetic and logic unit. Arithmetic and logic unit. That means this is used to perform arithmetic and logical instructions. Okay, arithmetic means you all know arithmetic, addition, subtraction, this and all, and also the logical instructions can be performed in this arithmetic and logic unit. Okay, and the next one is control unit. Control unit means this only controls all the operations which is done in this computer. Okay, and the next one is internal memory, or we can say it as register. Okay, the things which you give as the input will be saved in where? In the register. Okay, this register holds the instructions and the things used for processing. Okay, you will give a data and you will give a instruction, right? And this all will be holded by whom? By this register only. Okay, understood what is microprocessor? Next one is characteristics of microprocessor. Okay, this characteristics of microprocessor is a very important 5 marks. Okay, just mark it in your book and make sure first learn this question in this chapter. Okay, you have to just learn 3 headings. Okay, clock speed, instruction set, word size. If you know these 3 headings, you can study this. Okay, you have to study what is clock speed, what is instruction set, and another one word size. These 3 are the headings inside characteristics of microprocessor. Okay, this microprocessor performance depends on this characteristics only, these 3 characteristics. Okay, now we will see what is clock speed first. Clock speed, from the word itself you can understand every microprocessor will have an internal clock. Okay, this clock only will set up the speed of the execution of the instructions. Okay, in the first introduction itself I said computer means it will do any task we say, right? So we will give a task through the input. We'll say add this and it will process that and it will give you the output, right? Here it is clock speed. This clock only says to do the task in this speed. In this there is an internal clock there, and this microprocessor has an internal clock, and this only says the speed of the execution of the instruction. Okay, we'll give an instruction to the computer and that instruction will be processed in the speed of the internal clock which is present in the microprocessor. Understood? And this clock speed is measured in megahertz. Okay, we'll say it as MHz. Hertz means Hz. Okay, this clock speed will be determined, or this will be measured in megahertz or gigahertz. That is GHz. Okay, that is gigahertz or megahertz. Okay, clear? Are you clear about the clock speed? Clock speed means microprocessor will have an internal clock and that clock decides the speed of the execution of the instruction. That is clock speed, and this is measured in gigahertz or megahertz. Okay, clear about clock speed? Next one is instruction set. That also from the word itself you can say. Instruction means what? It's a command given to do a task, right? Here instruction set means basic set of machine level language instructions that a microprocessor is designed to execute. That means we'll have a command to say to computer, right? A command which is given to a computer to perform an operation on data. We'll give a data and we'll say the computer, will instruct the computer to do a task. That is instruction. Okay, here in this microprocessor, a basic set of machine level instruction will be given to the microprocessor. Whatever the instruction is given, that will be executed by the microprocessor. Okay, this is called instruction set. Clock speed, you understood, it is the internal clock and it decides the speed of the execution. This instruction set is instruction. Whatever you are giving, that instruction will be done by the microprocessor. Okay, the instruction which is designed to be performed by the microprocessor. Okay, that is given in what? Machine level instruction. Okay, that whatever instructions we give, that will just change the code, right? That will change into the machine level. Machine level means the language which the computer can understand. Okay, that is this instruction set carries out some types of operations. Okay, let's see what are they. Data transfer, arithmetic operations, logical operations, control flow, input output. These things you have to learn. Okay, clock speed means you can write it by your own. Instruction set means you can write it by your own. In this instruction set we have some types of operations, right? In this instruction set we have data transfer. First the data will be transferred, right? Data transfer, and then arithmetic means arithmetic operations will be done. Logical means logical operations will be done. Arithmetic and logical. First data is transferred, then arithmetic operations, logical operations, and then the control flow, then that will be controlled. Arithmetic means arithmetic, logic means logic, and then the control flow. Arithmetic, logical, control flow, and at last input output. Understood? There is nothing to study there. If you just remember those things, what is done? First data is transferred, and then arithmetic operation, logical operation, control unit, input output. That's all. Okay, in this instruction set we have this set of operations done. Okay, are you clear about this instruction set? Next one is word size. That also we can say it from the word size itself, right? The number of bits that are processed by the processor in a single instruction. Okay, in a single instruction set, how many number of bits can be processed is by the processor is called word size. Okay, this word size only determines the amount of RAM also. Okay, the number of bits that can be processed by a processor in a single instruction is called the word size. And the second point is this only determines the amount of RAM that can be accessed by the microprocessor. Okay, at one time. And the total number of microprocessor means this is the microprocessor. Okay, I have said to you about the first microprocessor, Intel 4004, right? This Intel 4004 has this much pins. Okay, the total number of pins on the this pins, maybe some pins will be input pins and some will be output pins also. This pin in the microprocessor will be determined by the architecture of the microprocessor. Okay, the microprocessor means it will have some pins, right? In this, some pins will be output pins and some pins will be input pins. Okay, so you have learned the characteristics of microprocessor question here itself, right? Is it easy? Characteristics of microprocessor means first you have to keep in mind the three headings: clock speed, instruction set, word size. Okay, clock speed means microprocessor will have an internal clock and the speed of execution will be determined by the clock. That is clock speed. Next one is instruction set. Instruction means the command which we give to perform a task is called instruction. In this instruction set we have data transfer, arithmetic operation, logical operation, control unit, and then at last input output. Okay, and then last one, word size. Word size means the number of bits that can be processed by the processor in a single instruction set is the word size. Okay, are you clear about the word size, clock speed and instruction set? That's all. You have learned the characteristics of microprocessor, right? And now we'll move on to the next topic. The next one is data communication between CPU and memory. Okay, this data communication between CPU means central processing unit, right? Memory, we have memory data register, memory address register, and what else we have? Now let's see it in detail. Okay,
see, the first commercial microprocessor is this Intel 4004. Okay, this 4004, from the name itself you can keep this in mind. This is a 4-pin. This has 4 pins. Okay, always the output pin and input pin will be same in this microprocessor. Okay, here they have 4 input pins and 4 output pins. So this is a 4-bit microprocessor. Okay, 4-bit processor, and it can process 4 bits at a time. Okay, this is manufactured by, I told you earlier, whom? Intel, and clock speed is 740 kilohertz. Okay, the size of this is 10 micrometer. Okay, the transistors 2300 transistors, and data with this 4 bits package is 16 pin. Again, this Intel released some other microprocessors also. Have you heard Intel 8085? This is a 8-bit processor, okay? And the next one is Intel 8086. That is 16-bit processor. And now currently, if you see this, we have 32-bit microprocessor, 64-bit architecture and all. They are doing microprocessors. Okay. Next, we are going to see data communication between the CPU and memory. Okay. Here there is a central processing unit and a memory RAM, right? The central processing unit has a MDR and MAR, right? This MDR is memory data register, okay? MDR, memory data register. And this MAR is memory address register, okay? The CPU has memory data register and memory address register, okay? This memory data register will keep the data which is transferred from between the memory and CPU, okay? Then next we have a PC, okay? PC is program counter. This is an important 2-mark question. When you see this in your book, you just underline that and learn it when you read itself, okay? PC is a program counter. This is a special register in the CPU which always keeps the address of the next instruction to be executed, okay? We'll have instructions to do a specific task, right? When you are doing, when you are writing one exam, and sometimes you'll think, right, next what question I'm going to write. When you are completing the 1-mark questions, you'll have a thing in your mind that you are going to write the next 3 marks or 2 marks, right? Likewise, the next set of instruction that has to be executed will be stored in a special register, okay? That is program counter, okay? This program counter is a special register in the CPU which always keeps the address of the next instruction to be executed. Are you clear about this program counter? And the arithmetic and logic unit of CPU has the address of the memory to be fetched into the memory address register. We saw about memory address register, right? Memory address register and memory data register are inside the CPU. And here arithmetic and logic unit of the CPU will place the memory which we have to get. Fetch means which we have to get. That one it will place into the memory address register. Okay. Then bus. Bus means it is a collection of wire. Okay. In this computer application, we'll say the bus as a collection of wires which is used to communicate between the internal components of computer. Okay. Whatever electronic devices you see, they are connected by using wires, right? The collection of wires which is used to communicate between the internal components are known as bus, okay? Bus is a collection of wires used for communication between the internal components of a computer, okay? And in this diagram also you can see a data bus, okay? With this data bus only these are getting connected, okay? The address of this bus, the address bus is used to point the memory location. Okay, this address bus will be there. This will point the memory location. Okay, a decoder, a digital circuit is used to point to a specific memory location where the word can be located. Okay, we are having word. This word will be located in a specific memory location in a point where this digital circuit, a decoder, in this, if you see, this has a specific memory location. So in the specific memory location only, this word is located. Okay. The address register is connected with the address bus. Okay. Is it clear? Address bus means I said earlier, it is a collection of wire to connect the components which is inside the computer, right? This address register is connected with the address bus. This will provide the instruction, okay? Instructions address, okay? The address of the instruction will be provided by this address bus, okay? Then what is the use of data bus? It will transfer the data between the memory and CPU. Data bus means it will transfer the data between memory and CPU. Okay. This data bus is a bidirectional bus. Why they are saying it is bidirectional? Bi means two, right? Uni means one, right? Unidirectional means only one way. This is two way. This is bidirectional means this is two way. Two way means the data will be carried from the CPU to the memory and also from memory to CPU. Okay. This data bus is bidirectional, but this address bus is unidirectional. Only one way the data will be transferred in the address bus. Okay. So data bus is bidirectional, address bus is unidirectional. Okay. The control bus controls both the read and write commands. Okay. The read operation will be taking the data from the memory and it will transfer to where? Memory data register. Okay. The single control line will perform the two operations. That means here we'll be saying in binary only. Okay. 0 and 1. 0, yes means we'll say it as 1. No means we'll say it as 0. Likewise, read and write operation also will be performed using this 1 and 0. Okay. This write operation transfers the data from the MDR to memory. Okay. Read operation means this operation will get the data from memory and transfer it to the MDR. Write operation means it will transfer the data from MDR to memory. Okay. Can you understand the bus connectivity between the CPU and memory? Okay, next we'll see about the memory data register. Okay, see, in this RAM and this memory data register will have the same size. Okay, same size means the number of bits will be same. I'll say it for an example. If you take the processor Intel 8085, that is Intel 8085 means it is a 8-bit processor, right? Here, this MDR is 8-bit and the word in the RAM, both this MDR and the word in the RAM, both will have 8 bits. Okay. If the size of this MDR is 8 bits, this can be connected with the word in the memory, which is also 8 bit size. Understood? If it is 4 bit, it can be connected with the word in the memory, which is 4 bits. Understood? The data bus will have 8 parallel wires which transfer either from MDR to word or word to MDR. If it is given 1 means in that read operation will be done. If it is given 0 means write operation will be done. Okay, clear? The read operation means this transfers the data from, what did I say? Word to memory data register, right? Write operation means the data will be transferred from memory data register to word. Is it clear? Read operation, the data will be transferred from word to memory data register. Write means the data will be transferred from memory data register to word. Okay. Next, we are going to see about the types of microprocessor. Okay. This classification of microprocessor will be based on two criteria. Okay. That two are, one is the width of the data that can be processed. Okay. A microprocessor will have a limit, right? Will have a limit that this much width of data only can be processed. That is the first criteria. And the next one is the instruction set. Okay. Now let's see the classifications of microprocessor based on the data width. Okay. That based on the data width, the microprocessor can be classified into 8-bit processor. If it's a 8-bit means 8-bit processor, 16-bit processor, 32-bit processor, and 64-bit microprocessor. Okay. If it is classified based on the data's width, we will say the classifications as 8-bit microprocessor, 16-bit microprocessor, 32-bit microprocessor, and 64-bit microprocessor. Okay. And the classifications of microprocessor based on the instruction set means, see, this instruction set is a important criteria which is considered when we are classifying the microprocessor. Okay. See here, this microprocessor has only initially in the beginning stage, in the at the time of the microprocessor inventions and all, if you see, it will have only a small instruction set and will need a expensive hardware. We'll need a big complex hardware to build it. As the technology grows, as we are finding the new things, that this disadvantage has been solved. Okay. And and to increase the functionality, the microprocessor has been developed, and based on this instruction set, this microprocessor has two types of classifications are there in this microprocessor. Okay, we'll see that. First one is RISC and the next one is CISC. That means RISC, that is reduced instruction set computers, complex instruction set computers. Okay, RISC stands for reduced instruction set computers, and this is classified based on the instruction set, right? So they are giving reduced and complex instruction set computers. Okay, that is RISC and CISC. Okay, this reduced instruction set computers will have a small set of highly optimized instructions. Okay, this complex instructions are also implemented using the simple instructions. Uh, how they will do means they will be reducing the size of the instruction set. Okay, the example of RISC, this reduced instruction set, means from the word itself you can write the definition also, right? Reduced instruction set computers means small set of highly optimized instructions. Okay, the example of this RISC processors are Pentium 4, Intel P6, AMD K6 and K7. You just underline these lines in your book, and this may come for 1 words or 2 marks also. Okay, this RISC and CISC, study clearly and just underline the words in your book. Okay, and CISC means it is a complex instruction set computers. This supports hundreds of instructions. Okay, this computer supporting CISC can accomplish a wide variety of tasks, making them ideal for personal computers. From the word itself, you can say complex instruction sets means how big task it is. This CISC can complete it very easily. Okay, this is used for our PC and for personal computers and all. This complex instruction set computers are used. Okay, the examples of this CISC processors are Intel 386 and 486, Pentium 2 and Pentium 3, and Motorola 68000. See, this Pentium 2, Pentium 3 and all comes under CISC, and this Pentium 4 comes under RISC. Keep it in mind. Okay, this will come for 1 word. They may ask Pentium 4 is the example of RISC or CISC. You shouldn't confuse it. Pentium 2 and Pentium 3 are CISC, and Pentium 4 is a RISC. Okay, next we are going to see about memory devices. Okay, just like a human memory, this memory device also will store the data and information. Okay, this computer memory is the storage space in the computer where the data and the instruction what all will be saved. Data and instruction will be saved. Okay, there are two types of accessing methods. First one is, as I said before, read and write. Okay, they are sequentially access and random access. Okay, the access means read or write, both sometimes reading or sometimes writing. Okay, this will be done in the memory. One is sequential access and another one is random access. Okay, sequential access means the memory is accessed in an orderly manner. That means first one from the starting to end. First one means first one, next one means next one, like that. Random access means any byte of the memory can be accessed directly without considering about the previous one. Okay, if you are giving a paper first, number one is giving a paper first, and number two is giving a paper next, 3 4, likewise if you are giving, if I am correcting it, first paper first, second paper second, that means it is sequential access. Okay, and if sometimes everyone has submitted the paper here, I am randomly taking number 35 out and I am correcting, that means that is random access. Understood the difference between sequential access and random access? Various memory devices are arranged according to its capacity, speed and cost. Okay, when you see this diagram, you can understand. If you see from here, from down to up means it has smaller capacity, faster access time and higher cost. That means older days they had only cache memory. Cache memory means the capacity will be small. Okay, capacity will be small. It fast. It can be accessed fast, and the cost also will be high. Right side, if you see the hard disk, it has larger capacity and slower access time, since it is having a larger capacity, the access time will be more, right? So slower access time, and the cost also will be low. As the technology goes by, the cost of making also they have made it small, and the cost is also lowered. Okay, next we are going to see about RAM means random access memory. Okay, the main memory is called as RAM. Okay, this is available in computers in the form of ICs. You would have heard ICs, right? ICs means integrated circuits. Okay, RAM is the main memory, and in the computers it will be as ICs. Okay, it will be in the place where the operating system, application programs, and the data is currently in use. Okay, this are kept temporarily so that they can be accessed by the computer's processor. Okay, this will be kept temporarily where the operating system, application programs, and the data are used. Okay, this memory, this is a small unit of information only can be stored in the memory as called in a bit. Okay, the memory can be accessed as a collection of 8 bits. That means we'll say it as a byte. Okay, collection of 8 bit means we'll say it as a byte. Okay, byte will denote that byte in capital B. Okay, bytes will be referred as capital B. Okay, if a computer is 1 megabyte of memory means, then it can store 10,48,576 bytes. Okay, bytes of informations. Okay, that means 1 MB is equal to 1024 KB, right? 1024 KB means 1024 KB is 1 MB. Okay, that 1 KB means 1024 bytes. Okay, so 1024 into 1024, 10 lakhs 48,576 bytes. Are you clear? 1 MB is 1024 KB, 1 KB is 1024 bytes. Okay, RAM is a volatile memory. Okay, volatile means what? It is not a permanent one. It is a temporary one. As soon as you switch off the computer, the things which is stored, or the things which you are using, you are reading or writing, will be lost. Okay, that is RAM. RAM is a volatile memory. This is not a permanent memory. This is just a temporary memory, which will be deleted once you switch off the power. Okay, and next we'll see the types of RAM. We have two types. Basically, we have two types. Okay, DRAM and SRAM. D means dynamic RAM. S is static RAM. Okay, dynamic RAM means this is a common type of RAM which we need to refresh it frequently. Okay, if you are using this dynamic RAM, the processing, what process you are doing, you have to refresh it. You have to keep it refreshing frequently. Okay, in the same way, if you are doing this static RAM, this don't need to be refreshed more often. Okay, um, once in a while we can just refresh it, or else no problem. Okay, this makes it faster. Okay, static RAM is more expensive than the dynamic RAM. Okay, next we'll see about ROM. ROM is read only memory. Okay, read only memory means this is a special memory in a computer which the older ones, or the which the pre-recorded data at manufacturing time, which cannot be modified. Okay, ROM is read only memory. Read only memory means we can just read that. We cannot change anything from that. When the computer, or when the CPU is designed itself, some codings will be uh, saved there, that we can just see. We cannot change anything from that. Okay, the stored programs that starts the computer or performing some operations will be available in ROM. Okay, this stores the critical programs such as booting the computer. That means loading the computer. Once the data has been given into the ROM chip, it cannot be modified, or we cannot delete it also. Okay, this means it retains its content even when the computer is off. Okay, whatever is there will be there even the computer is off. If you are working or if you are not working, whatever happens, this ROM will have its data by itself. Okay, and so this is a permanent memory, right? So we'll say it as non-volatile memory. Okay, RAM is a volatile memory. ROM is a non-volatile memory. Non-volatile means permanent. ROM is a permanent memory, and from that name itself you can say read-only memory. We can just read it. We cannot delete or change anything, even a single word in the ROM. Okay. Then the next one is, we'll see the types of ROM. First one is programmable read-only memory, PROM. And the next one is erasable programmable read-only memory. We'll say it as EPROM, EPROM. And the next one is electrically erasable programmable read-only memory, EEPROM. Okay. We'll see the types of ROM in the next session. Okay.
That's all for today. Thank you for your valuable time. Make sure you read the portions whichever you learned today, okay? Or else you won't remember it after 1 week. You just read whatever is given in the book. You read the whole thing in the book and just take a computer note and write it down. Write notes as you can understand, okay? So that it will be useful for your final exams. Understood? Okay, make sure study before attending the next session, okay? Thank you for your valuable time. Stay home, stay safe, take care, bye.